Hi, I'm Sam, and I'm an OpenSciEd teacher and facilitator. And today we're here to talk about the lesson 10 from the bath bombs unit. In this lesson, we're going to run electricity from a battery through water. The students want to do this. I love to do this. I mean, who doesn't want to run electricity from a battery through water? So let's take a look at what we're going to do in this lesson. How did we get here? In the last lesson, we figured out a lot about what particles are doing when we heat water. And we figured out a lot about density and solidified our thinking around properties. So in this lesson, we're wondering, when energy from a battery was added to water, were the gases produced made of the same particles as were produced from heating the water? Let's take a look at a lesson at a glance to see how we're going to get our students to answer this question. This lesson is an investigative lesson, and it takes about 1 day. There is kind of a lot of prep required. It's about 120 minutes, but it's worth it. And there are some hands-on investigations. If you're not allowed to have open flames in the classroom, on the OpenSciEd website, there is a student-facing video that you can use. There's also a teaching-facing video to show you how to set up the lab. We begin the day by reminding ourselves why we would want to add energy from a battery through water. The students then look at a setup to see how we could safely collect gases that would be produced when energy from a battery is added. We then test the gases for their flammability. We have a quick conversation around the similarities and differences between what happened in lesson 9 when we added heat and collected that gas versus adding energy from a battery and tested those gases. And we end the lesson by having our students construct an explanation as to whether the gases that were produced in lesson 9 are the same as the gases that are produced in lesson 10. What did we figure out in this lesson? We figure out that the two gases that are produced when energy was added from the battery are different gases based on their properties. That must mean that the particles that make up these gases are different from each other and also different from the ones that were produced from heating the water. We also figure out that the matter that makes up all of the substances must come from the matter that made up some of the original particles. So what are some key moments that we want to make sure that we're taking a look at to help our students get through this lesson? The first one is navigation. Remember, our students were probably having difficulty navigating to lesson 9. This one probably is not as difficult for our students, but we want to elevate the adding the energy to water poster to help our students understand why we're going to do this experiment. So have this poster available. We also want to remind our students of what we just figured out in the lesson before when we tested the heated water, that when we heated that water, we did not produce new particles. In part 3, when we test the gases, I want to really make sure and reiterate that it's super important to practice that test before you do it with the students. Make sure that the students are writing observations in their notebook. This is a sample of one of my students' notebooks and what it would look like, because they're going to need to use these notes later on when they construct their explanation. And then finally, after testing, don't have the students go back to their seats immediately. Lead a conversation with your students to help them compare the gases that we tested in lesson 10 to when we tested the gas in lesson 9. We really want them to see that they are different gases and that they're going to be, that while in lesson 9 they're made of the same particles, in lesson 10 they're not made of the same particles. Ask them to use evidence and really point to our key model ideas poster here. So what are some tips and tricks? All right. So when you're setting up your electrolysis investigation, first start by watching the video on the OpenSciEd website. One thing that's suggested is to daisy chain the batteries to produce the gas even faster. Now, I don't recommend using more than 3 batteries here, because if there's a problem with one battery, the whole setup doesn't work. But when you do daisy chain the batteries, it does make the gas go faster. I suggest collecting several test tubes full of gas ahead of time because I typically test each gas at least 2 times per period, because sometimes when you do this test, it doesn't work. And or sometimes the students were like, the test goes so fast, oh, I missed it. Can you do it again? So have multiple sets of each gas A and gas B, ready. I suggest using, and the teacher's guide suggests using distilled water as opposed to tap water, and that you add Epsom salts to the water so that it acts as a catalyst and the reaction does go faster. In part 2, when you have the students observe the setup, consider having several setups in various stages running to have the students look at. This way they can see what's happening at the different stages. You can see the water levels going down, and it also helps the students to see the amount of gas being produced. You really want to help the students notice, don't tell them the answer, but again, help them notice that gas A, or gas with the tube A, has much more gas in it than tube B, because that's going to help you in lesson 11. Now, one thing is that the water may turn pink, and while this does indicate that a chemical reaction is taking place, it's really not important for the students to notice or to see at this point in time. In part 3, when you test the gases, sometimes testing the gas does not work. So something I do, and you may want to consider, is have the students facing video up and ready to play as a backup in case the 2 gas tests don't work. B is especially like where I seem to have the problem. You may also want to consider having the students use the Some Common Gases data table to identify the gases in tube A and tube B at the end of testing. This will also help you when you get to lesson 11. In part 4, where you have the students construct the investigation, you're going to have the students answer the lesson question. The question is, when energy from a battery was added to water, were the gases produced by this made of the same particles as were produced from heating the water? Some things you may want to consider before having the students answer this question. I do use this as a summative assessment, so I have the students, and again, consider it, have the students make a gotta have it checklist. What's pictured below is one my students have made in the past. I also allow my students to use their notebooks because that's where their evidence is going to come from. Consider allowing students to use their notebooks as well. Poster management. You're going to want to make sure that you have these 3 posters. The ones about the particles that we made in lesson 8, the adding energy to water, which you also made in lesson 8, and your key model idea poster posted and readily available for students to look at in this lesson and that you can refer to. So to summarize, testing the gases is super important here and a lot of fun, but we want to make sure that we lead a conversation around comparing the particles that were produced in lesson 9 to the ones that were produced in lesson 10. We want to be sure that our students understand that the properties and the particles are changing in the electricity experiment when compared with the heated water, because we're going to leverage these ideas at the beginning of the next lesson. And again, I hope to see you in lesson 11.